So the last couple of segments I've been directing you towards a problem that we're almost ready to solve, but I want to tell you how we're going to use the process, and then in the next segment we'll actually crank out an example. If you recall, the unit tangent vector is pretty simple to calculate. You calculate velocity and you make it a unit vector. But to calculate the principal unit normal vector, that's quite messy. So we've shown that the tangent and the normal and the acceleration are in the same plane, and that we have these two scalars. We have the tangent scalar, and we have the scalar that goes with the normal component. And in the previous segment I showed you possible formulas for these, but those are pretty cumbersome. We will not prove or finish deriving these little pieces, but I do want to provide them to you. The scalar associated with tangent can also be written as a dot product of velocity and acceleration divided by the magnitude of velocity, or you could think of this as acceleration multiplied by the unit tangent vector. These are going to be pretty simple calculations. It'll be pretty easy to find this, I claim. To calculate the scalar that goes with the unit normal vector, there are, I would say, two reasonable possibilities, but I lean towards this one. It says if you were to calculate the acceleration, which will be an easy calculation, it's just the second derivative of the original position. If you were to find the magnitude of that vector and square it, and subtract this other scalar a sub t squared. This, remember, when you take a magnitude you get a scalar value, it's not a vector. The difference of these squares and then the root of that is actually going to calculate for you this other missing scalar here. Once again, I sadly won't have a proof for this in the at least the near foreseeable future, but we're going to use these calculations. Now, this segment's purpose is just to sort of point out the pieces. Here will be the goal. We wish to find this. We've seen that it's really messy, even with the simplest of possible functions. But imagine we had a vector over here called acceleration, and we had a scalar multiplied by another vector plus another scalar multiplied by n. I think we could solve for this. I think we could solve it. I think this would not be a difficult solve at all. Put a vector here, put a scalar here. I mean, this could be, for example, 2 and 3. Just distribute the 2, subtract this vector, divide by 3. Solving for n should not be too difficult. It might even be fun. Factorial. We shall see, though. We'll take it for a test drive on a function we would never use the formal definition of normal vector for. And we'll walk through setting up these pieces, and you'll see it may have a more simple little tasks, but it will not be one big giant messy calculation when we're done. We will find this normal vector through a better method. Come back for the next segment.